Okay, now we move on to question 13b. Question 13b. So first of all, based on the information, the question say that now these two spheres, they are melt, and then we class into two solid right circular cones. So and then the keyword here, please always remember, we cast. Actually, it means the volume of them is never change. And then that's why maybe in coming we need to use the equation to just write down the volume have no change and then try to find some unknown we need to find out. And then now, because we want to find the volume of them first, so that's why maybe we better also find out the larger sphere, the volume is equal to what. So based on the part A, we know that the sine ratio of two spheres is actually big to small is 3 to 2. So this is the sine ratio. So if we find out the volume ratio, want to find out the volume ratio, then the larger volume to the smaller volume will be according to the ratio, the quip of 3 over 2. And then which means 27 divided by 8. And then because in part A we already found the smaller sphere volume, the volume of the smaller sphere. So that's why we can quite easily to find the volume, okay, of the larger one this time, the larger sphere this time. Okay, and then that will be equal to 288 pi, and then divided by 8, and then times 27, and then that's why the result will be equal to 972 pi cm cube. Okay, and then now we already find out the larger and the smaller sphere, and then based on the keyword because, then we know that, okay, very important sentence is the total volume of two spheres will be actually equal to the total volume of two cones. Okay, and then because of that, the total volume of two spheres actually is 288 pi together with 972 pi. And then if you add them together, okay, that will be equal to 1260 pi. And then how about the total volume of two cones? One of the cone A, the question already gives us all the required information, such as the base radius and the height. We also know that. Then we can straightforward, okay, by the formula, volume of cone, to find out, okay, the area of the volume of cone should be equal to 1 over 3 pi times the square of base radius, which means 6 square, and then times the height. That is for cone A. And then how about for cone B? For cone B, okay, actually the formula is the same. It's 1 over 3 and then pi. And then the base radius this time is 12 and then square. However, we didn't have the height of the cone B. Never mind. We just denote by capital H first. And then also rely on this equation. You can find out the height, okay, of the cone B easily. So now we just try to solve it. So on the left hand side, the number is still 1260 pi. And then 6 squared times 10 divided by 3. And then that's why the volume of cone A actually is equal to 120 pi. And then for cone B, I don't know what is the height, but I can simplify the number in front of h. That means 12 squared divided by 3 will be equal to 48 pi, and then time capital letter H. After that, you can find out the height of cone B equal to 1260 pi, and then minus 120 pi, and then divided by 48 pi. And then the result of the height of cone B will be equal to 23.75. Okay, and now because we also found the height of cone B, and then we see one interesting thing happened. Based on the cone A and cone B, their side ratio, okay, that means the base radius of cone A, okay, to the same things, or B will be actually equal to 6 to 10. However, this is not equal to another side ratio. That means the height ratio, 10 to 23.75. And then that's why, because the side ratio of these two cones are not consistent. So that's why they are not similar. And then that's why the claim, okay, is incorrect. Okay, then this is about the question 13b.